Welcome everybody. We'll just wait a few minutes to get started in today's session. Thanks everyone who's joining us. Just going to wait a couple more minutes and we will get started in the lunch and learn. Okay, I can see people are starting to join us, so we will start things off today. So welcome everybody. So my name's Polly Goulet-Phillip and I'm the implementation lead at ecologiQ, and I will have the pleasure of facilitating today's lunch and learn. So before we get started and I introduce my panelists today, I'd like to do an acknowledgement of the traditional owners. So today, Wominjeka, which means welcome in the Walrong language of the Wurundjeri people, which is where I come to from you today in the beautiful, slightly overcast city of Naarm, Melbourne. But I'd like to acknowledge the traditional owners of the land on which we're meeting. And I'd like to pay my respects to the elders past and present, and any elders of Aboriginal communities who are here with us today. And I think really important to acknowledge the Indigenous approach to managing land and country, caring for country, build on the sort of core belief around, we look after country and it will look after us. And I think noting the topic today and the work we do at ecologiQ, really important, lots to learn for us. Okay, so today I'm joined by some really special guests from some of the Regional Rail Revival Alliance teams, and we're going to be discussing the innovative recycled materials that they've been able to integrate into their programs. So I'd like to welcome firstly Daisy Lippett. So she's the Sustainability Manager on the South Geelong to Warn Ponds duplication project. Now Daisy has worked in the construction industry for 5 years, and she's spent 3 of those on the Western Program Alliance Level Crossing project and the last 2 years with us on the Geelong Alliance Regional Rail project. And she's recently transitioned from an environmental field into sustainability and played a really fantastic part in contributing to the growth and application of recycled and reused materials and infrastructure. I'm also joined by Akash. So Akash is the Environmental and Sustainability Engineer on the Shepparton Line Upgrade, SCOO. Lots of acronyms in the Regional Rail project. Now Akash has worked in the construction industry and on the Shepparton Line project for the last 3 years, so has a really great knowledge and background on the different stages of the project. Now he started with the project as an environmental graduate, helping to deliver the IS rating. And he's currently working as an environment and sustainability engineer within the Alliance, delivering on the project requirements, which includes the implementation of sustainable and recycled materials. So thank you for joining me today, and really looking forward to hearing from you both around the recycled materials used on your different projects. So just before we kick off, some housekeeping. So please keep yourself muted. We will have time at the end for Q&A. And if we don't get to your questions, we'll try and respond to you via email as well. So please pop any questions in the Q&A. And you'll see the little icon on the bottom of the screen. Okay, so I will now hand over to our presenters, and they're going to give us a bit of an overview of their projects and talk to us about how they've managed to get recycled materials. Pass over to Daisy. Daisy, I think you're on mute. Just unmute yourself there.
Thank you, Polly. Still a novice with Zoom. Good afternoon, everyone. So firstly, I'll just quickly do an overview of the sustainable material initiatives we're using for the Warn Ponds duplication. And then we'll do a deep dive into the engineered containment of Category D soil. So we'll discuss what that is, the sustainability outcomes, the process to complete it, and also some of the project opportunities we've identified. And then we'll discuss some lessons learned that should be incorporated into future projects. You'll see on the top right-hand side, there's a brief overview of our project. So we're duplicating 8 kilometres of track, we're completing 2 station upgrades, and removing 2 level crossings with railover solutions. Some examples of the sustainable material project initiatives we're completing is the substitution of the steel mesh in non-structural concrete with e-mesh, which are recycled macro-synthetic fibres. We're also incorporating reclaimed asphalt pavement as much as we can on the project, and substituting concrete pipes with recycled plastic storm pro piping. So now it's time for the deep dive, contaminated soil reuse. So contaminated soil reuse is a permissible activity with EPA Victoria that requires an issued A17 permit from the EPA to complete it. The purpose of this is to create a meaningful, purposeful reuse of category waste soil that's sourced from a project to be reused within that same project area. The key thing is the reuse of the soil must provide amenity without causing any harm to the landscape or the community. For those that are unfamiliar with contaminated soil, I've provided just on the bottom left corner the different hazard categories of soil. So you have Cat A soil, which is obviously the most hazardous category, and then fill material, which is the least hazardous. Recently, EPA have created a new hazard category, Category D, just to account for that lower environmental risk associated with a lower level of contamination that could potentially be reused as long as the risk assessment is completed and you have EPA approval to do so. Some examples of the sustainability outcomes from the reuse of contaminated soil include a reduction in the carbon footprint associated with transport. For example, the soil's reused in close proximity to where it's sourced. However, on regional projects like ours, the closest facilities for disposal are over an hour away. And on top of that, we're also, instead of using clean material in these containment solutions, we're using the contaminated soil that was destined for landfill to be buried. So it's a beneficial reuse that supports the waste management hierarchy. The reuse of the soil as well can result in significant cost savings to each project. And it's important to consider as well that we're actually removing the current hazard from the environment and health risks from the community into a contained permanent solution. So the process for containment is a lengthy pathway, but can be done quite easily with enough project support. So the start of the process starts with the feasibility assessment, where you look at the solution, the opportunity that you have. You consider what that land use is, what the future land use is, who the landowners are, a cost-benefit analysis to check it's feasible for the project, and then also have a look at the future development potential of that land. If it's determined the feasibility is viable, you can then look at the current design or do any modifications to design to facilitate that reuse in that location. Once the design is finalised, you can then complete a risk assessment that accounts for any sensitive receptors that are nearby that reuse location. And then you can have a look at your reuse opportunity and run a series of models to determine the environmental risk. For example, in the bottom left corner, we have an infiltration assessment we've completed for one of our reuse opportunities, where we're having a look at the amount of water that enters and passes through that soil and if any contaminants might be carried with that water anywhere else and create environmental harm. If your risk assessment finds that the reuse is safe for human health, the reuse is safe for the environment, and it provides amenity for the landscape, you can then proceed to submit an A17 application to EPA. Whilst that's being processed, you can obtain landowner and land maintainer approval, amend your soil management strategy, complete any soil improvements that are required to that before you place it. This is an example of some of the soil improvements that may be required on your project. For example, when we started excavating the fill soils that were category D, we found we had a high amount of inert waste in it, of rubble and bricks and whatnot. So what we did, we passed it through a screen that you can see in the middle photo, which was 50 mil, which removed all the large aggregate, which improved the quality of the soil for reuse. In some applications, further geotechnical improvements are required to reuse the soil, and the project facilitated this with the application of lime, which generally is preferable to do in location. So as you place each layer of soil, you run a layer of lime. This also helps to remove any environmental risk because it locks in and reduces the leachability of the soil. Run through some examples of the opportunities we've identified on the project. So a lot of our opportunity comes from in rail embankment. So that's essentially, as you can see, the red in the red section of the figure below. It's the soil that meets the RE wall edge. So we utilised existing design for some opportunities, but then also modified some of the design that we could. For example, you can see in the green image where we had to actually bring up that subgrade level beneath the track. So we're able to modify the design to utilise additional Cat D in that permanent solution. So I'll provide an example of where we're at to date with one of the embankment reuse opportunities. You'll see in the bottom right-hand corner that drone footage, and you'll see it circled in purple. So that's approximately 11,000 cubic metres of category D soil we've placed there to date. So that's been screened and stabilised. Then we've obviously applied a polymer to it regularly to make sure it doesn't emit any dust during construction. We've also identified another 2,500 cubic metre opportunity of Cat D beneath the track, another 3,500 cubic metres within the station platforms where we could use soil to fill the platforms. And then we've identified another 2 areas of rehabilitation that present opportunity. This opportunity, you might be able to sort of see that we're actually realigning the rail corridor. So we're decommissioning that rail track, you can see, and moving it towards the right of the screen. Once we remove and reuse that ballast, we'll be left with a large void that has low amenity to any future land users. So our solution is to fill that void with the category D soil to level so we can landscape that area. This is another opportunity we just identified, which is in the same location, just on the other side of the track, where the design solution, the embankment of the rail actually immediately joins the embankment of a pre-existing road. And obviously these 2 embankments will have large maintenance requirements to prevent erosion. It'll facilitate speed of sheet flow. So we're currently doing a feasibility assessment to see if it would be beneficial to fill that area. And then if it is, we could substitute that with category D material. Now step into some of the lessons learned. I think it's important to consider the approval pathways for these opportunities, from design development to issue of A17 permit and landowner and land maintainer approval. Generally, we found on this project, the timeline takes anywhere up to 12 weeks, with 8 weeks of that embodied in the statutory approval pathway for the A17 permission. So it's obviously difficult to accommodate last-minute opportunities, so it really enforces that early planning is critical for success in a lot of the opportunities. The key driver of risk in the material for the reuse of the category D soil is the complexity of the material management strategy that you have and the need to be able to incorporate change into that strategy. The project at the very beginning developed a mass haul diagram where essentially we mapped all the soil that would be generated in each individual location at each different stage in the program. We then compared that with the reuse opportunities we had, how much we could fit there when the placement was required in terms of the construction program, and any foreseen risk where we might have to do soil improvements. This enabled us to identify the stockpiling requirements of the project. It's important to accommodate an extra risk value in the size of your stockpiling area, because if you find soft spots or for unforeseen reasons, you may end up generating more than you'd forecasted or expected to generate. It's also really important to consider proximity to public in these stockpiling areas, depending on what your soil is classified, or the nature of the soil, or any treatment that might be required, whether it be screening or stabilisation. They're dust emitting activities and sometimes quite noisy, in particular the screening of that material. So it's really important to make use of areas that are outside of direct proximity to public. An example of the challenges we had, I've provided a picture on the right-hand side of our project area. The blue and the green area is essentially where the Category D soil is being sourced from. And as you can see, it's a very confined rail corridor in very close proximity to the public. Therefore, for us to be able to complete the reuse strategy, we hauled it to the other side of the project that's shown in brown below. And you can see there's a lot of agricultural area there, and that prevented that public exposure and any other sensitive receptors. Largely due to the material management, we lost a couple of opportunities. And this is very early in the project, where the program where we're generating the soil is actually behind the program that we had for embankment. And that meant that when we weren't generating enough soil to feed the beast that we needed to place the soil in the embankments in the south. So essentially, we weren't able to utilise the full opportunities in both embankments because we just weren't generating enough soil. So we ended up having to substitute that with Site 1 clean field soil. Another unfortunate loss was the opportunity in station platforms. Obviously, you're not able to fit the stabilisation machinery to within a platform. So the project was going through the process of having ex situ soil improvement stabilisation completed on that material, but the approval pathway from that just outweighed the time that we needed to place that material in an occupation critical program. That being said, our current forecast of Category D soil reuse is at over 40,000 cubic metres in over 7 different locations in the rail corridor. And we're continuing to look for any other opportunities that exist as well. So I guess 40,000 cubic metres probably means nothing to most people. It surely didn't mean to me until only a year ago when I started to get involved in this, or a couple of years ago. So in the nature of, we've got the Olympics coming up, it's enough to fill over 16 Olympic swimming pools. So that's a lot of pools. So maybe when you're watching the swimming, you might think of this opportunity to use on your project. Thank you, everyone, for your participation in today's session. I'd now like to welcome Akash to present the sustainable material use at the Shepparton line upgrade.
Thank you so much, Daisy, and thank you everyone who joined in and all the panelists. I'm Akash. I work on Shepparton line upgrade, as Paul introduced me. Quickly, a quick overview of the Shepparton line upgrade project. The Shepparton line upgrade runs between Donnybrook and Shepparton. It's a regional project, and the plan is to get the velocity trains running on the line. So it's done in stages, stage 1, 2, 3. So 1 was just to have 10 weekly services. Stage 2 was upgrades at three stations in the Gambie, Mercedes, Murpnet, as you can see, accompanied by a Shepparton stabling yard where we did 2 stabling roads, and a lot of signaling 59 level crossings we commissioned across the whole stretch of 120 kilometers. And now we transition to stage 3, which is basically did the track upgrades to enable velocity trains to run from 110 kilometers an hour to 130 kilometers an hour. Signaling upgrades as required. Had road 3 added to the stabling yard, and minor works for culverts replacement, culverts repairs, track culverts, drainages. One thing which we also did was a Merchants crossing loop as part of our stage 2, which is a 90-degree bend. Moving on to the sustainable products we used on over the whole SKU project. So we managed to get, although being regional, we managed to get concrete mixes with 40% ACM into it. We also are utilizing e-mesh and MP47 fibers for reinforcement. We also did some of the fiberglass reinforced posts for the retaining walls for the ballast retention. We managed to get a lot of our Cat D spoil, which came out of our mud spots, turnouts, track works, into a legacy gold mine remediation in Indigo. And then we did, for the CSR works, we did signaling conduits, which are multi-layered sandwich conduits. Now I'll take you into detail of each of them quickly. So concrete mix first. So the project was able to utilize a lot of EnviroCrete concrete mix, which has 40% SCM. The major areas where this concrete mix were used were curves, channels, a bit of laydowns, a lot of road authority concrete mixes as well. Supply for us was Borough, and it was really good because it was a really good mix in terms of getting the transport sorted, logistical cost sorted, because it was based out of Shepparton. Next one is our concrete track sleepers. So concrete track sleepers are low gauge sleepers, and we replaced 55,000 concrete sleepers with timber sleepers with concrete sleepers. All our concrete sleepers had 20% SCM into it, which is slag. It came from Austrac, and it was a really good win for the project because it's a lot of precast concrete mix, precast concrete used on the job. Next one is Slickrit mix. The Slickrit mix has SCM as a crushed concrete, apart from slag or fly ash. So sometimes it's really hard to get a concrete mix which has like a coarse aggregate, which are used as an supplementary cementitious material. So our Slickrit mixes are non-structural. We're using it into the signaling location boxes, concrete pads. We have 41 pads to build. So instead of crushed rock, we're doing some concrete pads. So we're trying to utilize as much as we can. And Mawson's has that mix, which recently came up, and it's really good mix to be used. Next one, coming to our e-mesh and MP47 fibers. So e-mesh, as everybody knows, is a really good fibrous mix. It's a really good fiber, which is provides really good strength in terms of reinforcement. So we plan to use our e-mesh in our road or in a footpath extension we're gonna do at Mirupna Station. So we're gonna build a new footpath, and it's gonna have e-mesh as reinforcement instead of steel bars. It's a really good win for the project in terms of sustainability, because the footpath is over 200 meters, and we're going to utilize across 100-meter cubes of concrete, which obviously it has added benefits as well, because you're saving a cost on steel, you're saving your cost on manual handling, labor, and everything. So we're going to use that in our Young Street Mirupna footpath extension. We also used some culverts. So we did some culverts which came out of one of the suppliers, which had a mix of e-mesh and MP47 as reinforcement. So it was precast. Burrell supplied that mix as well. So it actually was a good win for the project in terms of all the reinforcement steel, which has to be used for a lot of culverts. And the culverts were in sizes between 600 millimeters to like 100,000 millimeters. So that's one of the good use on a project. Moving forward to the fiberglass reinforced I-beams. So during our design stage, when we were planning to do some retaining walls for ballast retention, because as part of the track works, it's about lifting the track a bit, and so you have to actually top it up much more ballast, so that it can have a better payload of the trains traveling on it. So our designers and us, we came up with a solution to replace the steel post. So fiberglass reinforced post reinforced I-beams are fiber and glass mixed reinforcement. So sorry, it's basically like a glass and fiber resin mix. It's manufactured through a pultrusion process, as you can see on the left hand side. And this post look exactly like steel, but they are similar sort of. It's a novel material. It's a similar sort of strength. More, I think it's more strength than the structural steel, and it helps, sort of construct, and we can cut it to size as well if we require it to. So we install across 400 of those across the Shepparton line. Moving on to our CAD-D spoileries. So we found a lot of CAD-D material. We found out was arsenic mercury impacted material. So there was no like better end use to it. So what we came up with is a process under EPA 1828 guidelines is you can have EPA-based designator, and then you can find an end use for it. So we had an EPA-based designator, and which had like specific requirements to be fulfilled for a gold mine remediation in Bendigo, which is like a legacy-owned orphan gold mine operated by DECA. So we transferred a lot of our CAD this fall in remediating this gold mine. Till we did 17,000 meter cubes till last month, before last month. And basically, it's more or less like a cost-effective exercise because it's a symbiosis, because the waste for one project or one industry becomes a waste for another, sort of becomes a source for or a product for another sort of work. So it's a really good outcome for the project. Now, moving on to our multi-layered conduits. The multi-layered conduits are sandwich pipe conduits. As you can see on the white layer in the between, it's a recycled PVC material. So these conduits are manufactured by Venedex. They are used as signaling conduits. We laid around 680 tons of it in ground already for our combined service route and signaling upgrade works. These products are really, really efficient in terms of compaction, mineral, everything. They don't deform. SKU project also facilitated the amendment of specification 733 for DOT. So we organized a site visit by surveillance officer, and we helped amend that so that these pipes can also be used in road projects and across Victoria. There's a link here. You can always go and check out a reform we did. We helped ecologiQ to do it. Now, some of the more products highlights which we use were recycled glass in our trenches. We installed some geometric sleepers in a stabling yard at Shepparton. We also did like recycled polymer flagging, as you can see, and EcoPost for our environmental no-go zones. And we also did some bidim green geofab across our laydowns and stockpile areas. So these are more of the projects. I can provide more information if you need on these products. And some of the sustainability wins and lesson learned on the project. So the good wins I can talk about is a lot of the products were as part of a project contract and a recycle first requirement, which is a really good thing because it helps drive the use of recycled material. Finding region locations or like supplies for region locations, and just do it at the very start. So it's a really good, it gets included in the design as well. And then you can also implement it thoroughly and basically get a good outcome out of it. We always workshop with our engineers and site supervisors so that they know about what we're doing. They know about the good news stories, or not the good news, but what the actual product or actual materials would do. We also get a Q discussion session with them sometimes so that we also understand like if that product is suitable or not. But it's a good workshop. It's a good workshop between us and the engineers, so which helps us drive more use of the sustainable products across the project. And then also some of the subcontractor engagement. So subcontractor engagement is most important because a lot of the works are done by subcontractors. So if you engage with them at the really start, or during the works they're going to do, you put them in their contracts. It's really good that you can get a good outcome out of it. Some of the lessons learned, obviously the budget and the product and transport cost. The cost is always a variable in terms of the regional areas, and specifically transport cost. So we need to ensure that our budget is actually aligned with all the works we're going to do, and also try like a middle point where we can meet and get things implemented. One of the things which I also learned was following up on site implementation, which obviously we lost a bit of an opportunities in terms of using a more selected mixes of concrete, which we could have used for different laydowns and different pads. So it's just keeping on track with everything is one of the lessons learned for us. And then, yes, as regional and rail project, it's sometimes hard to find some more sustainability opportunities, but if you keep your toes on the ground, the foot on the ground, you would always know. You can always look and find more opportunities where you can use all these products. These are really good products, and thank you so much, everyone, for joining in. And I would just hand over now to Polly.
Awesome. Thanks, Akash and Daisy. That was really interesting and a really great overview of your projects. So just a reminder to everyone online, and I can see there's a couple of questions in the Q&A, but please pop any questions you've got. And I've got a few to kick us off, and then we'll jump into the questions in the chat. So Akash and Daisy, if I can just ask you to pop your cameras back on. And I guess to sort of kick things off, I'm really keen to understand a little bit, and Akash, you just touched on it there, but what were the sort of challenges around sourcing and transporting some of those recycled materials, I guess, to the more remote parts of your projects?
So for us, as a Shepparton line goes, it's more like so Shepparton is a big city, but the stretch between Donnybrook and Shepparton, it's more remote. So the transport costs a lot of because a lot of the suppliers are based out of Melbourne, or maybe in south of Melbourne, or southeast sides of Melbourne. So it gets really hard when it comes to transport costs. So we actually had a bit of a we got a really bad, really high sort of transport cost for some of the products, like for example, Bidin grain. And it was not the material cost, but it was transport cost was too high for us. But it's just, as I said, it's a budget versus cost thing, which you do. So you try and find like a sustainable outcome for it in terms of cost as well, economy, social outcomes as well. So basically, just trying to work out with the engineers like what we can tick off and what we can do is the process we followed. But yes, it's still a bit of a challenge to get some materials because they are a bit costlier than Melbourne.
Yeah, and I think, noting the amount of materials you managed to deliver, it's a really great achievement. I guess just sort of Daisy, in terms of the kind of SCM mixes, were there sort of missed opportunities with getting some of those on site early?
Yeah, thanks, Polly. We did have quite a lot of regional challenges in the Geelong region with the availability of SCM. Firstly, I guess with precast concrete, I know there is industry challenges to adopting the higher SCM mixes because of the early curing strength requirements. The way the project overcame that boundary essentially was very early procurement. So as soon as design was at the quite progressed, The project engaged some precast suppliers and negotiated a way to achieve the highest possible SEM. We did have a really stringent program, so we weren't able to reduce the efficiency of the precast works, but they utilised the weekends. So we adopted the 25% mix, which enabled us to do our daily pours, but then adopted a 50% SEM mix on the Fridays, so then it could cure over the weekend. That really facilitated that precast. With ready mix, we had quite a lot of issues because there wasn't any facilities that had their plant configuration set up to incorporate SEM. So it ended up being, we worked very closely with the suppliers, and essentially they upgraded their plant and had 40% and higher SEM mixes available for ready mix toward the end of last year, which we're adopting now in all circumstances that we can. And in that meantime as well, we're working closely with Deakin University, and there was a master's student doing a body of work around incorporation of sustainable concrete mixes in the construction industry. And so we ended up utilising some of the findings from that master's thesis, and were able to apply 50% SCM mixes based on his work and obtain approval in a lot faster manner to, in some instances, apply 50% SCM mix prior to the plant upgrades as well. So that was a real win, but I guess it's all about that support to the industry, support to suppliers, contract agreements that provide assurance to the suppliers to do the necessary upgrades, and then it's beneficial for them in the long run, because then they can serve that that gap in the market that was currently there before we engaged. So
yeah, fantastic. And I think it's fair to say you guys have done a lot of the legwork now for future projects. Certainly looking at the supplier map on the ecologiQ Knowledge Hub, you can see more and more concrete plants have set up, and that's probably been driven by the work that you've all done. Okay, we might flick over to the Q&A. So I'll start off. I think there's a question from Kylie here around what level of cost benefit or penalty resulted from the use of sustainable or recycled options.
I could, oh, sorry, Cash. Oh, I'll just speak in focus to the reuse of Category D soil. It depends on the geotechnical quality of the soil, the reuse requirements of that soil. But for our project, the transport costs to dispose that soil an hour and a half away far outweigh any of the treatment costs. But it is, of course, under every circumstance, in every application, a really important consideration to do. Akash, I think I might pass it to you to describe some of those other materials you presented.
Thank you, Daisy, and sorry about that. So thank you, Carly, for the question. For us, as a project, because we had a lot of recycled materials being used, so from a cost-benefit perspective, as I said, only the transport cost, which came out of Melbourne, was a bit high for us. So, but as what we did was, for example, for the Cat D spot reuse, we saved a bit of money, a lot of money between us and getting used for the gold mine remediation, because the difference was the landfill levy versus what we are getting as a EPA-based designator, and we are helping DECA or another consultant out to actually remediate it. So a bit of money which was saved for the project, and then obviously we got some money from our different budgets to use on the sustainable materials. If we look at the cost benefits, it's not too far, honestly, for us. It was, I would say, a range of between $10 to $50 difference on a lot of the products. But it's more or less about the opportunity, and then again, all of the things playing with the approvals, with the properties, and the geotechnical stability and things like that, or so it's just finding the right beat and you just move with it. That's what we're trying to do.
Perfect. Thanks, Akash. And I think, yeah, worth noting, particularly with some of the e-mesh, it often does come back as a lower cost option, not using all the steel. couple of questions. So I've got one from Glenn here for you, Akash, which is around the benefits of those fibre reinforced beams that you used for holding in the ballast, and also if you can provide any cost equivalent to steel and who the manufacturer you used was.
Yep. First thing, so the fiberglass reinforced first. In terms of cost, it was comparative with steel. In terms of the other benefits, it's not a recycled glass material, but it's a virgin glass material. But with the fiber in glass, it provides the same strength as steel. And if you look at the energy value of it, it's lesser than, so the energy used to manufacture it is lesser than the 100% structural steel or 100% aluminum as well. So basically, it gives a lot of benefits from a embodied carbon emissions perspective. And the supply for us was Treadwell Group, and the beams are called Architects. Obviously, I'll provide more information on that. There's on my slides there notes, so it has all the information on that. But yeah, happy to provide more information on the product. Thank you.
Perfect. Thanks, Akash. And I think it's worth noting, although they're not made from a recycled product, there is definitely opportunity thinking about things like the wind turbine blades. I know that there's opportunity to use products that will be going to landfill, sadly.
Yeah, certainly. Yep.
Yeah. I might just skip on to a question for Daisy from Matt, which is around, probably more for Daisy. How did the high cement replacement concrete mixers perform in terms of construction, shrinkage, workability, curing times?
And we have had minor defects reported for some of the mixers because as they were early in VR approval, that hadn't been really trialed and tested. So that was at the beginning of the project, but they have since evolved those mixers and we're having a lot of consistency and success in the applications. We did have instances where it did delay program to get the required finish with the SEM mixers. So it did require a small amount of rework just to remove any inconsistencies that have come from the framing. But the cost benefit is still beneficial to incorporate that in terms of the rework that's associated with that as well. And again, I know Akash, you touched on it. It's really important to make sure that you're incorporating all these project requirements into your contract agreements. So all parties are sure of what the project expectations are in terms of the materials used and finished and any associated work that's required for that finish.
Yeah, thanks, Daisy. And I think, definitely worth noting, probably when you started pouring some of those mixes, there was probably a fair bit of behavioural change that was needed around how they were laid. And I know we found, similar things when I was at RPV, but I think it's fair to say that, for most of, we're seeing 70, 80% SCM mixes and the workability is, absolutely fine once the guys are sort of used to being able to use it on site. Akash, did you have anything you wanted to add around the workability?
So for us, at the real start Q2, we'd had some defects across some of the mixes we used. But over a period of time, because our processes are really straightforward with because the operators are part of an alliance, so we just go through defects with them. But after that, there was some changes in the VR mixes and everything, which has been done. And it turned out to be perfectly fine. I think we never had any defects over the past year and a half on any of the products we're using. So it was a really smooth process to use those 40% SCM materials on site.
Yeah, fantastic. Okay, one last question, and this one's for you, Akash, from Priya. She's just keen to understand if you can confirm around eMesh being used as a RIO in some of the precast drainage segments that you talked about. I think some of those culvert walls.
Yeah, sure. We've got the mixed design from Boral, which confirmed that. Because we are under the impression it was steel, but when we got the mixed design before, so it has written, it has like a different line, and it's like a confidential line from Boral to basically the supplier, because it got supplied from Boral to Milcast and Milcast supplied to us. So it has eMesh kg of dosage and MP47 is a kg of 4 kg, and also reconfirm that with the engineers from our suppliers, that is sure that it has no steel and it has used the e-mesh on it. And they were like, yep, that's correct. They are 50 MPa mixes. So I feel we were surprised, but it's a good thing that it's holding up in the higher sort of strength mixes as well.
Yeah, fantastic. Okay, sadly, I know there's still questions in the chat. We'll do our best to provide some answers to those, but that's all we've got time for today. So I guess, yeah, I'd really like to thank Daisy and Akash for their time and sharing all those valuable insights around recycled materials and, you know, the work you've done in you know, difficult regional locations. So yeah, fantastic to see. So for everyone online, today's session has been recorded and it will be available on the YouTube ecologiQ channel early next week. And I encourage you all to register for our next and final Lunch and Learn, which is going to be on Friday, the 17th of May. And that one's going to be looking at how the level crossing removal project inspired innovation to integrate lots and lots of recycled products into their Key and Parade level crossing removal project. So it should be a really interesting discussion next week. Okay, thanks everyone. Have a great rest of your Friday.